First rule is about conjoining conditions together using AND or operator. We'll first discuss conjoining conditions with AND to avoid nested if statements, when it's possible and when it enhances the readability. For each of the rules, I'll show you a code example and a truth table which I use to show you how the code executes on different inputs. Let's look at the code example. Here we see nested if statements. One comes right after the other. In the body of the outer if statement, there's nothing except another if statement that does not have any branches like else if or else. Whenever you saw a code that looked like this example, that is your clue that you may be able to conjoin the condition using an operator. Now let's look at the execution of this code. At the very top, we have a condition. It checks whether is Sunny is true or false. Let's first imagine is Sunny is true. Therefore, the program proceeds to the second line, that is again another if statement that checks whether temperature greater than 70 is true or false. Let's imagine that temperature greater than 70 is true. The program proceeds to the next line. It hits the return statement and it returns play outside, and the execution stops at this stage. However, what happens when the temperature is less than or equal to 70? In this case, the condition of temperature greater than 70 would be false, and the program skips the body of the inner if statement, and there's nothing in the body of the outer if to execute. Therefore, it moves to the next line and hits the return statement, and this time it returns play inside. And at this point, since we hit the return statement, the execution stops. Let's imagine is Sunny was false. If this condition was false, then the program would skip the whole body of the if statement, outer if statement, so it doesn't even check what's inside that block. When it moves to the next line, hits the return statement and returns play inside, and the execution stops. The reason that there is nothing in the truth table in front of temperature higher than 70 when is Sunny is false is that the outer if condition is false, so the program skips the whole body of if statement and it doesn't even check the inner condition. Let's look at the truth table. We can see that when both of these conditions are true, it means that when is Sunny is true and temperature higher than 70 is true, the code returns play outside. However, in all other situations, or when at least one of these conditions is false, the code returns play inside. Now let's conjoin these two conditions together using an operator as we discussed. I conjoin the conditions together. Now you can see that this new code does not have any nesting, and it's simpler to understand and modify. However, this modification did not change the code's behavior. While you do refactoring, you must make sure that your refactoring does not change the code's behavior. And let's right now check this code's behavior and make sure that we haven't accidentally changed it. Copy the truth table from the original code here, and now we are going to look at the execution of this new or modified version. So the code starts at the top. It checks whether is Sunny is true or false. Let's imagine is Sunny is true. Then it checks whether the temperature greater than 70 is true or false. If this condition is also true, then the program moves to the next line and returns play outside. Now let's imagine is Sunny is true, but the temperature greater than 70 is false. Because these conditions are conjoined using an operator, the whole condition will evaluate to false. Therefore, the program skips the body of the if statement and it moves to the next line and the code returns play inside. However, if is Sunny is evaluated to false, the program doesn't even bother checking the second condition because it knows that when conditions are conjoined using an AND, all conditions must be true so that the result would be true. This means
When it figures out that the is sunny variable is false, then it doesn't even check the rest of the conditions and the whole condition will evaluate to false. Therefore, it skips the body of if statement and moves to the next line and returns play inside. So the truth table stayed exactly the same as what it was before. And this means that while we improved the structure of the code, while we refactored the code, we did not accidentally change its functionality or its input-output behavior. Now let's talk about the concept called short circuit evaluation. We already saw it in the previous examples. So when we have conjoined conditions with and, as soon as the program finds one false condition, it stops checking the rest of the conditions and considers the results of all conjunction with and as false. So in the example that we just saw, when is sunny is evaluated to false, the program doesn't even check the second condition and it skips the whole body of if statement and moves to the next line. This is called short circuit evaluation.